Hey guys, welcome back to my channel. I am Karthik Agrawal, currently studying in Sri Venkateswara College of Engineering. Today we are diving into one of the fundamental data structures in programming, that is the linked list. Whether you are new to data structures or brushing up for an interview, this is the place to be. Let's begin today's video. So first, let us understand what is linked list. Unlike arrays, where elements are stored in a continuous blocks of memory, linked list stores elements on nodes non-consecutively. Each node contains two paths, the data and the link to the next node in the sequence. Now, let's see the types of linked list. The first type is the singly linked list. In a single linked list, each node contains two paths, data and a pointer to the next node. Nodes are connected in one direction, that is from the head node to the last node. The last node points to null, indicating the end of the list. It also allows dynamic memory management without needing a fixed size, unlike arrays. Now, let's see the transversing a linked list. Let's break down the simple algorithm for transversing a linked list. The process begins by initializing a pointer at the start of the list. We then enter a loop that continues until the pointer reaches null, indicating indicating the end of the list. Inside the loop, we print the values for the current node using pointer value, allowing us to see the data stored in each node. After printing, we advance the pointer to the next node with next. This method effectively lets us visit and display each element in the linked list sequentially. You can see the following code snippet which explains transversing of the linked list. Now let's see how we can insert an element in singly linked list. The following code begins by defining a node structure with has two components, that is an integer component and a pointer next to the next node. The create node function allocates memory for a new node and initializes its value. The insert at beginning function allows us to insert new nodes at the start of the list, updating pointers accordingly. We then have print list function, which transfers and displays the linked list. In the main function, we perform a few insertions and print the final linked list. The output confirms that the insertion was successfully demonstrated, the proper linking of the node. As you all can see the following code snippet, and I hope you all can understand it. Now let's understand what is doubly linked list. A doubly linked list is a type of linked list where it contains three major components, that is data, next pointer and previous pointer. Data is used to store the value in the node. The next pointer points to the next node or in the list, and previous pointer points to the previous node in the list. This allows for effective transversal in both forward and backward direction. Each node in the list is known as previous and next node, making it easy to insert or delete nodes at any position in the list. Now let's understand how can we insert a node in a doubly linked list. The code starts by defining a node structure with three components: an integer data, a pointer next to the next node, and a pointer previous to the previous node. We maintain global pointers for the head and last nodes of the list. The isEmpty function checks if the list is empty or not. In the insert first function, we create a new node and insert it at the beginning of the list, properly updating the pointers to maintain the doubly linked structure. Finally, the print list function transfers and displays the linked list. In the main structure, we insert a few nodes and print the finally doubly linked list, showcasing the proper connection in both directions. Now, let's understand circular linked list. A circular linked list is a type of linked list where the last node points back to the first node, forming a circle. In other words, the last element is linked to the first element and then and There is no null or end pointer. This means you can transverse the list in a circular fashion starting from the node and eventually returning to it. Now let's understand how we can insert a node in a circular linked list. As you all can see the following code, the code begins by defining a node structure which includes an integer data and a pointer next to the next node in a sequence. We maintain global pointers for the head of the list. The isEmpty function checks whether the list is empty or not. In the insert function, we create a new node and handle the insertion at the beginning of the node. If the list is empty, the new node points to itself, creating a circular reference. If the list already has nodes, we transfer to find the last nodes and update the pointer accordingly. The print list function transfers the circular link circular the print list function transfers the circular list and displays each node data, indicating the circular nature by returning to the head node. Finally, in the main function, we insert few nodes and print the resulting circular linked list. Now, you all may think, why do we require linked list instead of arrays? Arrays have fixed sizes and require contiguous memory location. This can be limiting, especially when you don't know in advance how many elements you will need. Linked list, on other hand, use dynamic memory allocation, meaning memory is allocated as it's needed, making it easy to add or remove elements without worrying about the size restriction. Linked lists aren't just theoretical, they're super useful for real world applications like managing dynamic memory in operating systems, building undo functionalities in software, or implementing complex data structures like stacks, queues, and graphs. That's all for today's video on linked list. Whether you are preparing for an exam or building a next project, linked lists are an essential tool in every programmer's toolkit. Don't forget to hit the like button if this helps you and subscribe for more deep dives into data structures and algorithms or for more interesting videos related to coding. Thanks for watching and I'll see you in the next one. Thank you.